We will continue with Mr. Kwan Chon with the gas management.
Selamat pagi, Bapak dan Ibu, dengan Ibu yang terhormat. Morning, ladies and gentlemen. My name is Kwan Chon. Very happy and honored to be here to share some insights about today's topic, gas management. So in the past decades, we are witnessing profound transformation of the energy consumption pattern. So we live in a world of data, whether it's your internet surfing, your movie streaming, it all consumes data. And then in the past 2-3 years, AI has become a hot topic. So this computation is rapidly becoming the single largest energy consumption worldwide. So if you look at these figures, so internet users have increased by 78% from 2015 to 2022, okay? Reaching a 5.3 billion of users. More dramatically, the volume of data has exploded by 5 groups in the same period, with projection of another 78% by end of this year. So in case you are not familiar with this zettabytes, so it is equal to 1 trillion of gigabytes. So this digital expansion comes with significant energy costs. So data energy use has grown by 70% in the same period. So to put this in perspective, it is about 1 to 1.3% of the total electricity demand. When we compare this to the entire nations, the scale becomes clearer. While not at the level of those major economies such as United States, China, but the data center energy usage has already exceeds the total electricity consumption of Indonesia, with a nation of over 280 million of people. So you can see that how power demanding is data center. So when we talk about data center, it looks something like this. Large industrial scale, square-shaped halls that contains vast computing infrastructure, such as computers, servers, and then all these facilities are typically owned by those cloud service providers, such as the Amazon Web Service, Microsoft Azure, or any other enterprise running their own operations. So as we saw in the previous slide, these facilities are very energy hungry. So and their consumption will continue to grow in the foreseeable future as our digital demand increases. We refer to all these facilities as the centralized data centers, massive computing hub, serve as the backbone of our digital infrastructure. So let us look at this map. So this map shows the landscape of the centralized data center globally. So the United States dominates the worldwide market, accounting for approximately 40% of the centralized data center capacity, with Virginia leading the way. Okay. In Europe, London set up as a container powerhouse with about 196 data centers, with its more proximity to those technology-based companies. In Asia Pacific, we also see robust development as well. Singapore, being a popular choice of regional headquarters for many technology companies, is hosting around 104 data centers. Even in Middle East, they have started their bigger role in data center industry as well. So it demonstrated that the digital infrastructure is becoming a strategic priority across all economies. So now back to our industry. So what was brought to us recently is a significant issue exists in the industry, the flare gas. So based on the reported figures, approximately 140 billion cubic meter of gas are flared annually. So to put this in perspective, if imagine Flare itself is a country, it will be the 5th largest gas consumer globally, ranking behind United States, China, Russia, and Iran. With the current natural gas price of around $14 per MMBTU, we are essentially watching tens of millions of dollars literally go out in smoke. However, this race has not gone unnoticed. Several global initiatives are to eliminate this flaring, including the World Bank Zero Routine Flaring Initiative and the Global Methane Pledge launched at COP26, which has been signed by 150 countries. Beyond the economic waste, there's also an efficiency concern. While those properly operated flares should achieve about 98% of combustion efficiency, the actual efficiency actually is closer to 91% based on some recent studies. So this represents an environmental challenge and a tremendous opportunity for the industry to capture value while reducing the emissions. And this brings us to where we stand today, facing two interconnected problems. Okay? The first one is the environmental challenge, obviously, it is substantial. So with the flaring efficiency of just 91%, we are seeing approximately 1 billion tons of CO2 equivalent emission annually. But the second problem is equally important here. So why our customers keep wasting the energy? Why do they continue flaring despite other alternatives? A simple short answer is other alternatives simply lack economic viability. So flare gas not only geographically stranded in those remote locations, they are also economically stranded. So what do we mean by that? It means that it simply cannot find its way to the market. While theoretically, those gas could be shipped to some distant market or to sold to some midstream operators, but the economy simply doesn't work out. So a $50 million pipeline investment cannot be justified with the volume involved here. Okay? So this fundamental economic challenge explains why the producer keep wasting such volume of gases. So let's see how we can help our customer meet with this problem. So we know data centers, they are power hungry, and then actually all these flare gas can be converted to electricity via gas turbines. So isn't this a win-win solution to integrate two of them? So data centers, in fact, they can be the buyers of all these stranded gas. We are not talking about those centralized data centers that we are discussing just now, but those which are scalable, modular, and can be put into a container. So this decentralized data center, we call it, would essentially function as the on-site downstream energy consumer. Okay? The customer can now have the possibility to sell the gas without need to worry about the infrastructure and the transportation costs. So instead of flaring the gas, we would now treat the gas to make it suitable for combustion in our gas turbine, and then produce electricity to power these modular data centers. And additionally, we will fix the problem at methane emissions. Okay? So the efficiency of gas conversion is 99.99% in our gas turbines, compared to just 91% of the combustion efficiency of those flare gas. It means we are actually improving the process by 80 times. So nearly eliminating methane emissions while simultaneously create value from what was previously wasted. So what we are witnessing here is the emergence of a powerful symbiosis between the oil and gas industry and the data center industry. So a mutual relationship which significantly benefit from each other. So the concept is simple. The containerized data centers modules would be installed directly at the oil and gas production locations. This creates an immediate on-site consumer of those gas would otherwise be wasted. The scale of opportunity is remarkable. The number of 140 billion cubic meters we mentioned just now. So we are now looking at approximately 60 gigawatts of consumable energy. Okay? That's enough power to run thousands of data centers, creating substantial value from what is currently treated as waste. So efficiency is obviously the main driver here, behind this symbiosis. So by partnering with the oil and gas producer, the data center now industry can secure reliable, cost-effective power while simultaneously helping to resolve a major environmental issue here. Meanwhile, oil and gas companies see this as a huge opportunity as well. They get to transform an environmental liability associated to their operation into a revenue stream without massive infrastructure investments. So this is the essence of the industrial symbiosis here. Turning one industry's waste into another's is an essential resource. So these are the process requirements. I mean, we carefully analyze when we approaching these flare gas utilization solutions. So it includes the gas compositions, the actual flaring rate with variability pattern, the operating pressure, the temperature at the flare point. So we can handle any kind of specification, but it is important to note that the technical complexity increases with the use case